Hi friends, Naji here. Welcome back. So we are continuing our discussion with LangChain, and in this video we will be discussing on LangChain Expression Language, that is LCEL. Okay, so before implementing the coding part, just have some more words about the LCEL. It is actually a declarative approach of building new runnables from existing runnables. So we already have done a video about runnables, and if you are not aware of that, please have a look on that. I will add the YouTube link in the description also. And when we do the LCEL, we actually says what we want to happen. Okay, and we are not saying how we want it to happen. So who will take care of the how part? So that is actually taken care by LangChain. Okay, since it is taken care by the LangChain, it actually optimizes the execution of chains. Okay, so that is the advantage of LCEL, and some other benefits like already mentioned, it's optimize the parallel execution, and it is guarantee async support, and it is simplify the streaming. Now we can see some of the code example. Okay, some of the code example, and here I have my Visual Studio code is open. I have my requirement is already run. Okay, this in the GitHub. Okay, now I'm going to import few libraries. Okay, so from core I'm going to import runnables. Here I'm going to import runnable parallel, and I need RunnableSequence, and I need RunnablePassthrough. I think that's enough. One more thing, RunnableLambda. Okay, so these are the runnables that we have imported. Now first we can see a function. Okay, you can call it as some function, and which will accept x, and it will return x plus 2. See, so this is a function. So we discussed this in our last video, how we will make it in a runnable interface. Okay, for that what we can do, I can create a chain. Okay, now here I can make a runnable lambda, then I can make it, then we can have a sum function. Okay, so now it's become chain, and I can invoke the chain like this 2. So we will have the answer 4. Okay, now we can check how this can be converted, or this can be converted into chain using pipe function or LCEL. For that what we can do, I can create a chain. Okay, I can use the function, some function. Okay, now I can have a runnable pass through. This is just a dummy function which will give some kind of a just pass through, that's it. Okay, so this will give indication that okay, the sum function is also a runnable. So what happened is that, okay, so here it says unsupported. Okay, let me check this. Some function unsupported operand types pipe model meta class. Okay, so here we have to have the runnable pass through, something like this. Okay, now it's fine. So we have a chain that is created. Now I can invoke this chain 2. We are getting the value as 4. Okay, so what is actually happening under the hood? Under the hood, this knows, the LCEL knows, okay, this is a lambda function, and it will automatically convert this into a lambda function, and this will execute that. Okay, and runnable pass through, as I mentioned, just a pass through function. Okay, nothing more than that. Now we can see how can we integrate this sum function with another runnable function. So for that, let me create a runnable 1. Okay, here I can create a runnable lambda. I can say lambda x. Okay, this is same example that we have discussed in our previous video. Okay, so this is the runnable 1. Okay, maybe I can add like 2 more runnables which needed in our example. So let me make it runnable 2. So what runnable 2 says that we can have a lambda function like this, and here this will multiply 2, and I can have a runnable function runnable 3, and here I can have a runnable lambda. Here I can mention lambda. Then whatever the input I will be adding okay, like final with that. Just I'm not sure I need the runnable 3, but let it be there. Okay, so we have the runnables. Now what we are going to do, we are going to create a chain. Okay, so first I will tell you what usually we will do. Okay, what we will do, we will create a runnable sequence, right? And we will create a runnable lambda. Then we will pass our we will pass our sum function here. Okay, then we will integrate it runnable 1. Okay, so here what we are doing, we are actually taking the sum function and we are converting that into runnables, and we are making a sequence of sum function and the runnable. Okay. Now we are going to invoke the function 2. So here we are passing the 2, and what is happening is that the sum function is actually adding that, then it will be 4, then we are calling runnable, so it will be foo 4. Okay, so it's working perfectly. Now we can see how can we convert this into pipes, okay, or LCEL. For that I can easily use sum function and I can use runnable 1. Okay, then chain dot invoke, I can pass the same input, we will have foo 4. So this is very simple. You can see earlier just to compare, you guys can compare these two chains, right? This chain and this chain. We will understand that how simple it is. Okay, now we can see here we have two functions, right? Runnable 1 and the runnable 2, these two functions, and let me make it a sequence and we can try to run that. Okay, for that what I will do, I can have a chain, and to make it sequence I can use a runnable sequence, then runnable 1 comma runnable 2, then I can invoke it 2, then this will be foo 2 and the foo 3. Okay, so here let me explain that. First it will come to the runnable 1, then it will be returning foo x, then it will be multiply it. Okay, so that's why we are getting 2 foo. Now this I need to make it like a function. So first let me have a runnable x sorry, it will be x, and what it does is it just return foo x. Now I will make runnable 1 sorry, now let me make runnable 2 x. We are accepting a x there as a parameter, then we are returning similar to the earlier one. What we are returning x comma 2. Okay, so this is the same function as these two, runnable 1 and the runnable 2. Okay, so this is the same function as runnable 1 and runnable 2. Now we need to chain these two functions. Okay, so I'm trying to replicate this particular statement. Okay, so here we have a chain, and what I can do, I can have a runnable function here, runnable x. Now I can have a runnable pass through. As I said, it's just a pass through. Okay, now I can have my runnable 2. Okay, now I can have invoke 2. See, we will have same output we are getting. So in this way, very easily we will able to pipe different runnables together. Okay. Now let me explain you one more thing, how we can execute the parallel functions with respect to the LCEL. Okay, so usually in my previous video this is already discussed, but again, so we will have a runnable parallel. Okay, now what we discussed in that video, we will have a first parameter as runnable 1, then we have our second parameter as runnable 2. Okay. Now I can invoke the parallel function dot invoke 2. So this will invoke in parallel. Okay, so here we have a first one is foo2 and second one is 2. Okay, because these are executing in parallel. Okay, now this is, we can write in another way just to make it clear. This is actually a dictionary. Here I can give a parameter like first, I can give any parameter. Here I am giving the runnable 1, comma, and here second, this is also key, we can give anything, any name there, and here we are giving the runnable 2. Okay, and I can run parallel dot invoke 2. See, this will run in this way. So whatever, so the goal that I am trying to say is that whatever we give in the dictionary, within the dictionary, that will execute in parallel. So for that, let me create a dictionary here. Okay, here I can say that key 1, here I am saying it is runnable 1, and key 2, we can make it runnable 2. Okay, so this is my dictionary and I want to make it parallel. For that I can have a parallel and my dict. Okay, to make it runnable I can use the RunnablePassthrough here. So we have our parallel dot invoke. I can invoke it to, so this is actually running in parallel. So we will have a foo2 and the key we will have a 2. Okay, so we can see how this mydict can be chained with another runnable. So here we have we already have a runnable 3 that we have defined, right? So what it does is it is actually with a text word final. Okay, so I can make it a final chain, and this will be our last example in this video. So here we will have a mydict and I am passing runnable 3. So we have our chain and I can have a final dot invoke. I can make it 2. Okay, we are getting an error because we cannot add this dictionary with a string. That's where we are getting this. For that, what I can do, maybe let me take the string to, I can make it string for the time being. I'm converting this into string to string. Okay, now we can run it. Okay, see, we are actually attaching final with the final result. Okay, so that is all about in this video. So we have discussed about LCEL and how can we implement that and the advantage of it. Okay, so we can have, like, we can come up with another video with more detailed information or details about LangChain. So please do like and subscribe. Have a nice day. Bye bye.